Hello, everybody, and welcome to episode 67 of the video series in which we program an entire video game from scratch, from beginning to end, using nothing but C. So, I know it's been a long time since I made a video. I've had a lot of stuff going on in my life, such as having a child. So, I've been taking care of a little newborn baby. That's been keeping me pretty busy, but he's taking a nap right now, so I have some time to record a video. You'll also notice that I'm wearing a green shirt, which is probably for the best because I probably have some slobber stains on my shirt from him. Before we begin, I wanted to show you guys something. I released a game on Steam recently, and I wanted to show it to you. It's called L Racers, and I obviously created it myself using all of the same technology that we have gone over on this video channel, video series. So um, I'll just show you what it looks like. So as you can tell, this looks pretty familiar if you've been following this channel. And you got the background music, you've got the menus, the keyboard input, exact same kind of code as what we've done with our other game. All it is a two-player snake-like game where you go head-to-head and you try to beat the other person, try to be the last alive. I've got single player versus CPU. I've got two players either sharing the same keyboard or using two different Xbox controllers. I've also got network games like the local area network. If you wanted to join a LAN game, someone else could go and host a game, and as soon as they hit host, their name would show up here in this list, and then you could go join their game. If I'm home alone right now, so I don't have anybody to help me test this to show it to you live on stream. But if my wife were home, she would be in the background and she could be hosting a game, and then we could play a network game. But for right now, we'll just do this. And as you can see, I'm on the left, and the CPU's on the right. We'll call it an AI. We just went right past each other. Alright, so we've both kind of blocked ourselves off into pretty small areas. And the CPU is really good. As you can see, I messed up there and accidentally killed myself. Play again. Also thinking of adding like random power-ups or something to the game. I think that would be cool. Like maybe one power-up that you run over and it like either freezes you or freezes your opponent. Another one that maybe like breaks through your enemy's tail or something like this. But anyway, he is in a death spiral, so I'm just going to let him kill himself. There he goes. Okay, so that is L Racers, and it's on Steam right now for $2. And if you find any bugs in it, please let me know. And if you wanted to leave a positive review, that would be awesome. So yeah, there you go, L Racers. So, but that's not what we're doing on this stream. We're actually working on another game. So let me fire that up. It's called. We still don't have a current. We don't have a good title for it, but the working title is called Game B until we think of something better. And I'll call it Game B because I already had a Game A that I was working on at the time. So here it is. So I've done a couple of small things since since the last episode, since episode 66. One of which was, I created the Overworld. So let's just fire this up real quick and take a look at it. As you can see, I've got different types of terrain: desert, grass, swamp, and a little town that you can go into, and that's pretty much it. And water, of course. And right now I'm stuck on this little island, so I can't really explore much else of the world. Um, the other thing I did was I made it so that the escape button, if you hold it down, it will fast exit the game no matter what part of the game you're in, and that's just for debugging. I'll remove that later on. But for now, let's see how. Actually, I want to go take a look at the overworld so that you can actually see what the whole thing looks like. Here we go. Assets, maps. Here we go. There you go. Now, as you can see, can I zoom in? Oh, sorry. This built-in viewer is garbage. So let's go in paint.net. Like it wouldn't let me zoom in. I was like holding down control. And anyway, here's the little island that we started on. But as you can see, I'm going to, it gets much larger. I've even got like snowy areas in the north, forests, and I've got hills and mountains and things like this. Bridges that go over the top of rivers, all this kind of stuff. So, um, I'll have to put more towns in. It's just missing like the towns, and I haven't really developed any lore for this video game yet. I mean, I haven't like named the continents. Although this continent over here looks a lot like a dragon or a phoenix, doesn't it? Which is pretty cool. Um, that was by mistake. I was just kind of randomly drawing. There you go. And then of course there's this over here. And if that doesn't look like an evil mastermind's lair, then I don't know what does. That's obviously where the final boss is going to be. All right. So I'm thinking it's out in the middle of the ocean. You're going to, at some point in the game, probably acquire a sailboat or a ship of some sort that you can traverse the oceans in. So there you have it. Did that. And, there's a bunch more tiles that go into this. And then I used the tiled application to create this map, which you probably remember from a previous video a long time ago. This is the program I used to create this map. It's called Tiled. All right. All right. So there's something that I've been wanting to do in here for a long time, which is simply to make our asset loading less janky than it is. So what do I mean by that? Let's go on down to where we load our assets. Oh, actually, hold that thought. There's two things I want to do. Okay, first of all, this guy right here. If you remember from a long time ago, in a previous episode, one of the viewers of this channel very helpfully created this for us and actually created a GitHub pull request, the very first GitHub pull request that we merged on this project. And this is it's a pre-computed map essentially that is used by our blitzstring function, and our blitzstring function basically just indexes into this giant array to figure out where the character is on the bitmap. Right. So if you recall, and again, I'm giving you a lot of a refresher here because it's been so long since we recorded a video. So I'm actually giving myself a little bit of a refresher too. Cancel. Open with. For some reason, open with doesn't work. I don't know why. Let's drag it in here. There we go. Here's our font, right? So all the letters are in a single line, and they're all like 6 pixels wide by 7 pixels high, right? And so for when you want to draw a string, you have to go and find each one of these characters, and that's what we started by doing this gigantic switch case for every letter, and that was pretty horrendous. So um, now we have this map here, and this map it definitely it's faster. It's faster mainly because not because it's pre-computed values, but mainly because it eliminates branching in the code, and I think that's the main performance win right there is the elimination of branching. There's no more switch case. There's it doesn't have to um, follow multiple branches every time you call the blitzstring function. But anyway, something just occurred to me just recently, actually, that it occurred to me when I was making L Racers, the other video game that I showed you at the beginning, um, because I was bringing over a lot of this same code right from this game, and I thought about this variable, and I thought, wait a second, this doesn't need to be a global variable here. I mean, the only place that this is ever used is in the blitzstring function, right? So why don't we just take this and make it a static variable inside the blitzstring function, right? And that gets us to that is a win for us 2 ways. Let me go ahead and do that now. All right, so I'm cutting out this global variable, cut, and now I'm going to go down to blit string to buffer, and I'm going to paste it right in here. And of course the formatting is a little wonky. We'll have to fix that. Now it's important though that we add static here. Remember that a static variable is only initialized once. And I need to rename it too now because it's no longer a global. So I'm going to remove the G there, and I'm going to go down here to our code and take the G off of it there. All right, should be identical. So I'll talk while I'm fixing this formatting. So this gets us. This basically gets us two small victories here. Number one, it gets rid of the global variable, which is nice because you shouldn't be afraid of using global variables. I know there are different schools of thought about when you should use global variables, and generally it's you should try to use as few global variables as possible, right? I'm doing this something like that, right? No, that's how it should look. Yeah. So anyway, using as few global variables as possible. Secondly, now if you probably are asking, well, is there any difference between using a global variable and a static variable within the scope of this function, like in terms of speed, performance, CPU cycles, storage space, all this kind of stuff? Obviously, there's no difference in the storage space requirements. No difference. The static variables and global variables are essentially stored the same way in memory, but there may be a slight performance gain here. And of course, it all depends on the context, and of course, you'd have to really benchmark it to be sure. And honestly, I feel like in this particular instance, the difference in performance is going to be, you may not notice it. But anyway, there is technically performance gain potential. There's a potential for performance gain that could be had here, and I'll explain to you why. Is that when you make this variable a static as opposed to being a global, it simply it tells the compiler that, hey, I now know that this function can only be accessed and especially modified from within this function. So I can perform some optimizations. The compiler can perform some additional optimizations to that end, right? Whereas if I left this variable as a global, the compiler may not know, well, it wouldn't know where else in my program, especially if I'm accessing this global variable from other compilation units, right? Like if it's an extern um, situation and I'm accessing the variable from other files, other compilation units, like the compiler would not know whether I'm accessing it from there or not, and it wouldn't be able to perform those optimizations. Um, it wouldn't be able to perform the same optimizations that it would be able to perform as a static variable. So that being said, again, I think the difference in this particular case is going to be very small, but it's also good because it gets rid of a global variable, and so we don't have to worry about accidentally accessing this from another function. So yeah, and just to make sure it still works, I'll run it. Yeah, it's working fine. The font, the blitzstring function is still working fine. Again, so I can just hold down escape now and quit and fast exit the game, which is nice. Good debugging feature. All right, so that's the first thing I wanted to do. The second thing I wanted to do is make our asset loading system better. So let me show you what I mean by that. Here we are in WinMain, right? And we go all the way through here to load assets somewhere in here. I have to scroll down here to find it. Create main game window, get file attributes. Oh yeah, we created a new thread. And okay, so the asset loading occurs on a separate thread during startup, and asset loading thread proc is the function where this actually takes place. So let me go to asset loading thread proc. All right, and then we have, here is what I'm talking about right here. So I basically just go through each and every asset in the entire game. So every sound file, every wave file, every OGG file, every BMPX bitmap file, of which there are many, every tile map. Okay, I'm just going through them over and over again. I call load asset from archive, load asset from archive, load asset from archive, load asset from archive, load asset from archive. And when you find yourself doing this sort of thing, you're probably not coding as like high octane as you possibly could. Uh, this is obviously repetitive. It's a waste of code. It's you know no, I don't like this at all. So what I want to do is I want to make this better, and also I want to make it better in two ways. I'm going to reduce the amount of code. I'm going to stop, repetitively calling this function over and over again like this in this style. Secondly, I have this enum right here, this enumeration, resource type OGG, resource type wave, resource type tile map, etc. I feel like that is completely unnecessary. I feel like we should be able to infer what type of asset this. I feel like we should be able to infer what type of asset we're loading based on the file extension of the asset, which makes this enumeration completely unnecessary, right? So what I'm going to do is I'm going to do that first. I'm going to take care of that first. So if I go over to main.h, I'm going to find that enum. Here it is. and I even left myself a note here to do. We probably don't even need this. We can just infer type from file extension. So obviously this is something that I've been thinking about for a long time. I am going to take this enum and I am going to delete it, kill it dead. Of course, when I do that, I'm going to have to update a few things. I'm going to have to update my function here, load asset from archive. This function right here, you can see it takes in an archive name, it takes in the file name of the asset, it takes in the resource type, and then it populates this void with our resource. But we don't want this resource type anymore, so I'm going to delete this. Okay. And I'm going to hit save. Now I'm going to go over here to main.c. I'm going to hit F12, jump over here to load asset from archive. I'm going to delete resource type. Okay. Okay, so now that I'm in load asset from archive, I need to figure out, okay, this is all going away. This switch case here, pretty much all going away. But first we have to get get like the file extension of the file, right? So here we are in the we've decompressed the asset file. We've located the asset file inside of the archive. We've decompressed it. No, we haven't decompressed it. Yeah, we have. Here we go. Yeah, extract to heap. So yes, we did. We have extracted the file. We just haven't turned it into the type of. We have this void star of memory, right? Just like this nebulous void void star. It's just data in memory, and we need to basically convert that into a resource type that our game understands. That's all. That's all I'm trying to say. So what I'm going to do is I'm going to go right here after the point where we could fail if we tried to look for a file that didn't exist in the archive. All right, so if we're here at this location, the asset file exists, and what we're going to need to do now is get the file extension of it. So I'm going to create a new local variable, and I'm going to call it, it's going to be a string file extension. Okay, so pointer. Okay, so we don't have to allocate, I don't think we need to allocate any memory for this. It's just going to be, I plan on this being a pointer that points to the, basically the existing file name, an index within the existing file name, right? It'll become more clear as we get more code laid down here. So let's see, what next? I got to find the file extension. So str length of asset file name. Okay. -1. I is greater than 0. I minus. So the idea here is, let's say if I have a file called, birthdaycake.bmpx. I'm going to start at the end of the file name and work my way backwards until I find the first period character, the first dot. And that's going to be my file extension, right? And so I don't have to I don't have to copy the string or anything like that. My file extension local variable is just going to be a pointer that points to that location right there, that dot. So what we're going to do is we're going to do file extension equals the address. Oh, sorry, the address of asset file name I. Right. So we're just working. We're starting at the end of the file name, working our way backwards. And if file extension equals a dot, then we're going to break. And simple as that, I believe we have our file extension. So now what we're going to do is we're going to, instead of doing all the switch case stuff, we're going to do if file extension and stri compare, which remember the I is it means ignore case. So this is a case insensitive compare. We're comparing file extension to BMPX, and if that comparison if that comparison is equal, then we're going to do BMPX. There you go. Cut, paste. Okay, and so forth and so on. We're going to continue down this path, doing all the different types of resource types that we know about. So next comes wave sound file, and we're going to, here we go. There you go. Next we do og, og, which is going to be right here. If next we do, only thing we have left is tile maps, which is TMX, right? Pretty sure that's TMX. There we go. And now we can get rid of this entire switch case situation. Oh, and finally, I'm going to add something for unknown file types. Unknown file extension. There. Okay, now we have this is still undefined. Okay, we need to remove this right here. Go through and remove all these. My son is waking up. I might have to take a quick break, depending on if he starts making noise or not. Just going to go through here, remove all these resource types. Okay, so that's, I mean, this is going to be a pretty decent improvement, right? Because we eliminated an entire enum from our code, and we reduced, well, we haven't reduced the code by that many lines yet, but we're about to. We're about to reduce this code by a lot. This is probably gonna, I don't remember, there's a lot of these for the player. Which is quite annoying. Okay, I think I'm done. run it and make sure everything still works. Looks like everything is working fine. All right, cool. So now the next part of this is I want to eliminate all of this repetition. This is just, real low energy, don't like it. So what I'm going to do is I'm going to all right, I'm going to go back up here to our asset loading thread proc up to the beginning of it. And I'm going to create a new type here, a new data structure. And I'm going to call it, we're just going to call it an asset, right? Type def struct asset. And notice I'm declaring it within the scope of this asset loading thread proc. So it's not a global, it's something that's only going to be accessed here in this function. And what is an asset? Well, it's going to have a name. It's going to have a file name, and it's going to have a destination. So this is going to be where it goes, right, in memory. It's going to be the variable that we're going to store it in, right? So that's our asset. And now that we have declared that, we define that data structure, I'm going to make an array, and I'm going to call an array of assets, and literally called assets, and then I'm going to initialize it thusly using, hold on, an empty, yeah, I'm getting there. Okay, so first, I'm going to initialize it like this, 6x7 font.bmpx. And we're going to store that in G6x7 font. Next one, we have splash screen dot wave. And we're going to store that in G sound splash screen, right? So forth and so on. I'm going to populate this variable, this array, with all of our assets up to this point, right? And then what I can do is simply go, and I don't know how I'm going to handle that quote unquote essential assets yet, but I'll think about it. I'm going to do a for loop starting at 0. I'm going to do for the count of assets. So it's going to loop through our array of assets. And for each one of those, I'm going to do essentially this. Right? If load asset from archive, only instead of that needs to be assets I dot name, and this needs to be assets I dot destination. And now this gives us the added bonus of being able to get rid of that, put a token there, and we will see function assets I dot name and error code. Okay, I think that is complete. Now all I have to do is go back here and finish all of my assets. which I'm going to do. Need to take care of my son real quick. Give me a few minutes. I'll be right back. I think what I will do is I guess I'll go here. If no, no, I don't like that. We'll do um, final essential asset index equals 1, right? 0, 1. If I is greater than, or let's just say equal to, final essential asset index back in our for loop, right? So when it equals 1, we will have completed the loading of splash screen.wave, and we can set the event. There we go. And again, as a refresher, in case you guys forgot, the only reason I'm doing this is simply thinking ahead. Maybe I might have lots and lots of assets, and it might take a long time to load. I'm basically saying that as long as I have the 6x7 font loaded and the splash screen sound loaded, then I can proceed with drawing the splash screen animation, the title screen, and I can continue loading further assets on this background thread, right, on this separate thread, without, causing the loading screen to take a long time. So I'm basically just trying to make the loading of these assets more efficient, even though with the amount of assets and the size of assets that we have, it doesn't really matter yet. But in another game, if you were loading, gigabytes worth of assets, it could make a huge difference. So anyway, there's that. So now I just need to go and finish out this array. Okay. So forth and so on. Okay, we did Overworld BMPX. Now we need to do Overworld TMX, just right there. Right there. Cool. Now we need to do menu navigate.wave. Cut. Delete. And there we go. Through the magic of time, I have completed the array of all of our assets. Just like that. So again, we created this new structure called an asset, which consists of a name and a destination. And then we made a big array of assets. And for each one of these, this is the file name of the asset as we find it in the archive, in the compressed archive, right? And when we extract it to heap memory and we store it in the destination, right there for each one of these. So we have a splash screen, overworld, BMPX, TMX, wave files, OGG files, all of these animated sprites, are all these different frames for our sprite animation, grasslands, dungeons, rats and slimes, etc. Right? And then we simply loop through them all and call load asset from archive in a loop. So now we have a load asset function that is much clean. It's much cleaner. It's more concise. It's like dozens of lines of code eliminated, and easier to maintain this way. So yeah, I'm definitely happier with this. Let's run it and make sure it still works. I forgot to do one thing. Okay, so on one hand it did work, but there's one thing I forgot to do. And wait, no, 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 it's fine. I think everything is working perfectly fine. Yes. So I'm pretty happy with that. And this way, if we ever decide that some other asset needs to be essential, we can just add it in here and bump this value up by 1, and then everything should work fine. Cool. All right, so that actually is all I wanted to show you guys today. Again, I know it's been a long time since I recorded a video. Hopefully, it won't be so long until the next one. Um, Also, please go check out my new game, L Racers. It uses the exact same technology as what you find in this series right here. So if you've been following along with this video series, then you have everything, all the knowledge required to go and create your own game from scratch that you can actually commercialize, right? Which would be pretty cool. So with that, I'm going to sign off for the day. As always, if you have any questions or comments about this video or any other video or anything at all, really, just leave a comment. I will respond to the most interesting comments as time permits. And also remember that all this code is up on GitHub, and you can download the code and follow along at home if you'd like. And yeah, follow me on Twitter, and that's all I have. So until next time, thank you very much for watching. Goodbye.